All right, this is the end of week 4, believe it or not. So we're doing some slope and graphing stuff all this week. Hopefully everybody's had a chance to find and explore Khan Academy a little bit, because we're going to start off with a little video from them that covers slope. I think some people are still maybe struggling with how to find slope in the different formats. And so maybe listening to Sal Khan a little bit, he's the founder of Khan Academy, maybe that will help a little. You know, because we start off with this unit talking about 3 primary forms of lines, right? Slope intercept, that's the most common, y equals mx plus b. Standard form, ax plus by equals c. We can convert those into slope intercept if we solve for y. So today we're also going to figure out how to find the intercepts, regardless of which form of the equation that we're dealing with. And we're going to look at the third style of linear equation, which is point slope. Point slope is not my favorite for a couple of different reasons that will probably become obvious as we get into it. But point slope is very handy in certain situations. So anybody have questions about any of the things that we've been working on so far? Well, that's good.
And this blue line. And what we'll see is this notion of steepness, how steep a line is, how quickly does it increase or how quickly does it decrease, is a really useful idea in mathematics. So ideally, we'd be able to assign a number to each of these lines or to any line that describes how steep it is, how quickly does it increase or decrease. So what's a reasonable way to do that? What's a reasonable way to assign a number to these lines that describe their steepness? Well, one way to think about it could say, well, how much does a line increase, or how much does a line increase in the vertical direction for a given increase in the horizontal direction? Let's write this down. So let's say if we increase in vertical for a given increase in horizontal, for a given increase in horizontal. So how could this give us a value? Well, let's look at that magenta line again. And let's just start at an arbitrary point to that magenta line. But I'll start at a point where it's going to be easy for me to figure out what point we're at. So if we were to start right here, and if I were to increase in the horizontal direction by 1, so I move 1 to the right, back on the line, how much do I have to increase in the vertical direction? Well, I have to increase in the vertical direction by 2. So at least it looks like our increase in vertical is 2 whenever we have an increase in 1 in the horizontal direction. And we could, let's see, does that apply? Let's see, does that still work? If I were to start here, instead of increasing the horizontal direction by 1, if I were to increase in the horizontal direction, let's increase by 3. So now I've gone plus 3 in the horizontal direction. Then to get back on the line, how much do I have to increase in the vertical direction? I have to increase by 1, 2, 3, 4, 5, 6. I have to increase by 6. So plus 6. So when I increase by 3 in the horizontal direction, I increase by 6 in the vertical. We're just in between lines. For example, this.
Well, I lost my place there. My point here that I'm going to try to emphasize for you is this is exactly what we were doing when we were finding slope from a graph. You notice how he was counting the squares? And this is also why I've tried to emphasize that you need to reduce your fractions every time you end up with a slope that's a fraction. Because I know these little triangles that he made here look different. Obviously, this one here from -2 up to the x-axis and over to 1x is bigger than the other one. But it's the same relative measurement. It's the same increase in both the y direction and in the x direction. So if this particular triangle here is 6 vertical change, and he was counting the squares, 1, 2, 3, 4, 5, 6, and the horizontal change is 1, 2, 3. Well, what's 6 over 3? 2. You reduce it to 2. 6 divided by 3 is 2. 2 over 1, it's the same slope. So that's why reducing these fractions to their lowest terms, anytime you're dealing with slope, is a good idea.
Increase by 6, so plus 6. So when I increase by 3 in the horizontal direction, I increase by 6 in the vertical. We're just saying, hey, let's just measure how much we increase in vertical for a given increase in horizontal. Well, 2 over 1 is just 2, and that's the same thing as 6 over 3. So no matter where I start on this line, if I take and if I increase in the horizontal direction by a given amount, I'm going to increase twice as much in the vertical direction. So this notion of increase in vertical divided by increase in horizontal, this is what mathematicians use to describe the steepness of lines. And this is called the slope. This is called the slope of a line. And you're probably familiar with the notion of the word slope being used for, say, a ski slope. And that's because a ski slope has a certain inclination. It can have a steep slope or a shallow slope. So slope is a measure for how steep something is. And the convention is we measure the increase in vertical for a given increase in horizontal. So 2 over 1 is equal to 6 over 3 is equal to 2. This is equal to the slope of this magenta line. So slope, so let me write this down. So this slope right over here, the slope of that line is going to be equal to 2. And one way to interpret that, if you, for whatever amount you increase in the horizontal direction, you're going to increase twice as much in the vertical direction. Now, what about this blue line here? What would be the slope of the blue line? Well, let me rewrite another way that you'll typically see the definition of slope. And this is just the convention that mathematicians have defined for slope, but it's a valuable one. What is our change in vertical for a given change in horizontal? And I'll introduce a new notation for it. So change in vertical, and in this coordinate, it's going to be, the vertical is our y coordinate, divided by our change in horizontal. And x is our horizontal coordinate in this coordinate plane right over here. And you might say, wait, you said change in, but then you drew this triangle. Well, this triangle, this is the Greek letter delta. And it's a math symbol used to represent change in. So that's delta. And it literally means change in y divided by change in x.
Now, right here on this screen, he's already got this description up here above, increase in vertical over increase in horizontal. He's saying that that's slope. Now he's adding another one here, this delta y over delta x, change in y over change in x, y2 minus y1 over x2 minus x1. Okay, hold on just a second. Why are we sharing our screen, Stephanie? No, don't do that, please. Okay, so remember, I've said before, there are multiple different ways to describe slope. Right off the bat here, he's figured out or showing us the first one just to be able to count the squares on the graph. We can find the slope.
So if we want to find the slope of the blue line, we just have to say, well, how much does y change for a given change in x? So the slope of the blue line. So let's see. Actually, let me do this. Let me do it this way. Let me have let's just start at some point here. And let's say if my x changes by 2, so my delta x is equal to positive 2, what's my delta y going to be? What's going to be my change in y? Well, if I go to the right by 2 to get back on the line, I have to increase my y by 2. So my change in y is also going to be plus 2. So the slope of this blue line, which is change in y over change in x, we just saw that when our change in x is positive 2, our change in y is also positive 2. So our slope is 2 divided by 2, which is equal to 1, which tells us however much we increase in x, we're going to increase that same amount in y. And you see that. You increase 1 in x, you increase 1 in y. Increase 1 in x, increase 1 in y. From any point on the line, that's going to be true. You increase 3 in x, you're going to increase 3 in y. It's actually true the other way. If you decrease 1 in x, you're going to decrease 1 in y. If you decrease 2 in x, you're going to decrease 2 in y. And that makes sense from the math of it as well. Because if your change in x is negative 2, that's what we did right over here. Our change in x was negative 2, we went 2 back, then your change in y is going to be negative 2 as well. Your change in y is going to be negative 2, and negative 2 divided by negative 2 is positive 1, which is your slope again.
Okay, so I would encourage you guys to get to, like I said, to get on to Khan Academy. And whoever is coughing, could you please mute yourself? To the third style of equation for these linear situations. Okay, we're going to be looking at this particular handout to start with. It says we got a given equation in point slope form that satisfies the given information. Okay. Probably don't remember, or maybe you do. Maybe you do remember what point slope form looks like. So I'm gonna pause one more time. From the class materials. Point slope form is that equation that's in the middle of that top group. First equation on the left is that slope intercept that we use all the time. Point slope form is a little different. And you got to pay attention to what some of the symbols mean in here, or it says M is the slope. Well, M is the slope in slope intercept also, so that's good. Both of these first two forms here, slope intercept and point slope, both have the slope in them. We like that. We want that. Slope intercept is more generic. Point slope is specific to a point. Every point on a given line is going to be able to generate its own point slope equation. Because this x1, y1 here, that is actually a single point from the line. The tricky part about point slope, you've got subtraction in the front, subtraction in the back. So your signs are going to change from whatever they are on the point that you're plugging in there. And it's the reverse of what we get used to doing. How many times have you heard me say x comma y, x comma y? X first, y second. Well, not in point slope. Point slope is the reverse. The y value comes first. So again, this is in the materials. This is the algebra reference sheet. I want to keep this handy. maybe even print it out if you get a chance, because these first 4 equations here are all extremely valuable for what we're doing right now. And if you notice the 4th one, that's where you get into the calculation to find slope when you have 2 points. Some of the language is the same as what Sal was talking about, change in y over the change in x. The y value from the second point subtracts the y value from the first point. That's your change in y. You can always do that if you have the ordered pair information. X2 minus x1 is always the value on the bottom. And I want to emphasize that because it's a common mistake that I see a lot, is that people will flip these. They'll get them upside down. They'll put the change in x on top instead of the change in y. Well, when that happens and your calculations are correct, I know that that's what you did. So if I see that, I'll try to make a comment about it, upside down. And what I mean by that is that you got the wrong parts of the ordered pair on the top and the wrong parts on the bottom. But I want to go back to point slope form. And I need to use my whiteboard for that. So if I'm going to use point slope form, this is the form of the equation. Y minus y1 equals m times x minus x1. And these boxes, that's where the value from a point comes in. You put the x and the y in there with their sign. You notice I did not include those minus signs. That's because you're going to subtract that value that you plug in from the other y. So in the end, we're going to end up back in slope intercept form after we've done some substitutions. Because I'm also going to take the slope and substitute it in there into that circle where m is. And so what that creates is a kind of distributive property problem on the right-hand side of the equation. If I solve one of these point slope problems for y, for the simple y, I will get slope intercept. Now, the cool thing about point slope, the one cool thing is that you can use the point slope information to graph just as easily as you can the slope intercept information. The only difference is going to be your starting point. With slope intercept, where are we going to start? What do we use to start a graph with slope intercept? What? Oh, B. We use the y-intercept. We use B. B for beginning. That's where we start. If we were going to graph in point slope, we would just use the point that we're given. The second movement is going to be the same. We're going to use the slope to put a second point on the graph. So at least from a graphing standpoint, the only difference is your starting point between slope intercept, which is y equals mx plus b, and point slope.
So what was the first equation?
The one on the left?
That was points.
This is point slope form. We've already done some work in slope intercept. We've done some with standard form. We're going to do more with that today also. So what is the problem that we're going to look at here for point slope? Okay, it's got the very first one there. It says we got a line that's going through 2, 3 and has a slope of -1/2. Point slope form. So here's the ordered pair, 2, 3. The slope is -1/2. So I'll end up with y minus 3 equals -1/2 times x minus 2. Y value goes here. X value goes over here. It's backwards from what we normally talk about. And if you notice, originally the ordered pair were both positive terms. Now they're both negative because that minus sign changed the signs. You guys are going to get tired of hearing me talk about signs, but it's true. It's the biggest mistake area, and this is another example of that. Questions so far? All right. So if I want to convert this into slope intercept, let's say I'm not a fan of graphing in point slope, and I want to convert it to slope intercept. How am I going to solve this mess for y? What's the first thing I should do? What do you mean combine? I don't see any like terms. I see a y, I see some integers, I see an x. Where do you see like terms? The 2's inside a parenthesis. I heard somebody out there say multiply. That's absolutely, yeah, that's where you're going to start. We still have to follow handouts. We're going to multiply. This is distributive property multiplication. Y minus 3 equals -1/2 x. Half of 2 is 1. It's a negative times a negative, so that's going to be +1. Okay, now I'm a little bit simpler, and I'm one step away from solving for y. Now I can think about combining like terms. I can add 3. That 3 is on the wrong side of my equal sign, though. Remember, this divides my problem. So now I've canceled that -3, and I have a slope intercept equation that I'm more comfortable graphing. -1/2 x plus 4. The hardest part about point slope is getting the substitutions done correctly. So let's look at another example. So number 3, a lot of times in class, if we're all together, I'll say, let's do the odd number problems. Reason for that is if you can do these correctly in half the number of problems, everybody's happy. So now we're passing through 0, 2, and our slope is -5/3. I'll just save that. Okay, 0, 2. Negative 5 over 3. Y minus, here's my y value from the point. Just going to label it y1. There's the circle where I had the slope. X is part of the permanent equation. Subtract the x value from the point. Be x1. Okay, so what goes in that first box? 2. 2 goes in the first box, right? Dos. And what goes in the circle?
Negative 5 over 3.
Yes, don't forget the minus sign. Negative 5/3. And so 0 has to go here.
Yeah. Yep.
Okay. That 0 there kind of simplifies things a little bit for us because we still have to do the distributive property multiplication to get rid of that parentheses. Right? I mean, that's following PEMDAS. If we can't solve it, we can at least simplify it. And negative 5/3 times 0 is still 0. It just ends up with a blank there. So I'll bring down this left side. Y minus 2 is negative 5 over 3x, period. I don't have to put the 0 there. So now all I got to do is add 2 to both sides. I'll put the 0 there as a placeholder just so you can get used to seeing that B term out there to the right. Don't need it, but at least in this case, you can maybe see what it's supposed to combine with. So here's my slope intercept equation, y equals negative 5 over 3x plus 2. Now I'm completely comfortable graphing that when I go and start at 2. My y-intercept is right here at 2. I'm going to go up 5 and left 3. 1, 2, 3, 4, 5. Up 5, left 3. Line with a negative slope goes something like that. And you know, it's about as simple as I could make it.
So because you have the fractions, you went over 3 and up 5, right?
No. I did the rise first, but it doesn't matter.
Well, I know
It doesn't make any difference.
2, but I'm talking about the fraction. Because I get where the 2 went on the line.
Yeah.
But the fraction, you would go over 3 on the bottom and then up 5, right?
You could do it that way. Or I could have gone to the right 3 and down 5. Remember, it doesn't matter which one of the numbers in your fraction is negative, as far as we're talking about slope. If either one of them is negative, you have negative slope. So if I go left 3, that's minus 3. When I go up 5, that's plus 5. So now I got mixed signs, which means in a fraction it's negative. If I go to the right 3, 1, 2, 3, down, let's see, 1, 2, 3, 4, 5, here. Now if I go the other direction, I'm going to end up on the line no matter what, as long as I repeat the correct sequence and the correct number of spaces in the move. Because now I'm going to the right 3 and down 5. down 5 is still negative. And when we talked on Tuesday, if I was clear up here at the top of the graph, if I had a point way up there, can I go up 5 and left 3? No, I'm off the graph. So reverse everything. Because it's the same thing. It's still a negative over a positive, or it's a positive over a negative. It's a negative. Negative slope. It's a good question. So what's next? Ooh, number 5. What are we going to do with that one? Do we have everything we need to write point slope with number 5?
No.
What are we missing? The slope, right. So here's where the slope calculation comes in. Slope calculation, y2 minus y1, x2 minus x1. All this is a comparison of the y values, because that's going to be your change in y, divided by a comparison of the x values. So the ordered pairs I have are -4, 6 and -2, 5. That's a 2. One thing I always encourage people to do is, until you get good with this, try to stick some labels on these numbers so you can follow where your substitutions need to go. X2, Y2. And all it means is this is X and Y from the first point. This is X and Y from the second point. It'll at least help you get them in the right order. So 5 minus 6 and -2 minus -4. So on the top, I got -1, keep change on the bottom. It's like -1/2 is the slope. Great. So to write a point slope equation, which one of these points do you want to use? No, and that's, you've nailed it there, Tony. It does not matter. However, it might be helpful if you pick the one that's got all even numbers. Yeah. And the only reason I say that is because once you start putting it into point slope form, if you have to convert it, solve it for y, and change it into slope intercept, here's your number that goes in here for m. -1/2 is going to be multiplied against your x term. Well, at least there you got an even number. So you're not going to get a fraction or some decimal. And no matter which one of the points you choose for point slope, if you convert it into slope intercept, it's going to come out the same. Because they're telling you that both of these points are on the same line. So doesn't it make sense that the slope intercept equation would have to be the same for both these points? Yeah. It has to be, or they're not on the same line. And they've already told us that they are. And remember, early on today, I said point slope gives you a unique equation for any point that's on the line. Point slope is very specific. Slope intercept is generic for all the points on the line. So y minus -4. And then we got -1/2 x minus, oh, I got that number in the wrong place. I did it already. See, this is why this drives me crazy. Should have been a 6 there. And it's not negative. Y value in the front, x in the back. There's your minus minus. So y minus 6, -1/2 x. Now this 4 becomes positive. So -1/2 times 4 is -2. Cancel the 6. Yeah, this is the other reason why I don't like point slope so much. You got a lot of signs to try to keep track of. -1/2 x plus 4. And if I had done the same thing, in fact, I'll go ahead and do the other one also. And I'll show you how they both end up with the same slope intercept form. Y minus 5 equals -1/2 x minus -2. Y minus 5 -1/2 x becomes +2, so this is -1. Add 5. So when you got 2 points, what you can see here is that it becomes an extra step to find the equation first, or excuse me, find the slope first. But after that, it's just plugging in the numbers, you know, into the little boxes, if you will, and doing the simplification on the right. And then canceling that other y term, your actual number from the point, to convert it into slope intercept. This is a literal equation now that we've solved for y. We got the y by itself. And we're doing the same thing at every step of the way here as we've been doing on all these equations that we're solving. We're following the distributive property here. Over on this side, we're using our opposites to get rid of these terms here, the 6 and the -6, or the 5 and the -5 on the other one. And we're doing it on both sides. We added 6 to both sides on the left one. We added 5 to both sides on the right. So we're keeping these things in balance. Question, anybody? All right, now I want to give you guys a chance to write up one of these point slope equations. Actually, no, we won't do that. We'll see how good you are at analyzing, because if you can understand what's in these point slope equations the way they have them written, that'll actually probably help you learn how to create them better, maybe even than actually drawing them up. So the slope in any of these 7 through 12, the slope is easy to identify. What do we look for in point slope when we're trying to find the slope? Yeah, because that's where M goes. First number after the equal sign. It's the number right here. In each of these, it's modifying against that quantity in the parentheses. So finding the slope is the relatively easy part. The trickier part, though, is the second half of this little section here. Name a point on each line. So what is the ordered pair for the point that is described by this point slope equation in number 7? Now I want to know what the ordered pair is for the point that is in that equation. Okay, these are all in point slope form already. I want to know what the ordered pair values are for the point that is used to create that equation in number 7. It's backwards, and check your signs. Flip it again. No, you got to flip the signs, not the numbers. You had the numbers in the right order that time, but not the signs. 4, -2, right. And this is why this is a perfect example why this is confusing, because again, the y value is in the front, the x is in the back, and the signs are opposite from what they were when it was just an ordered pair. Because our temptation is, like you start off, Kathy, you said 2, -4. Okay, that's just pulling the numbers straight out of there, but that's not what they were originally when it was just a point on the line. That's the tricky part. All these are going to be like that. If you look at number 9, the original ordered pair was -2, -5. Because that's actually -2 and -5. When you simplify it and rewrite those, that's what you end up with, because that keep, change, that minus creates a positive sign. What about number 11? Good. -1, 8. You got it. What about 10? Nah. You can't, it's not solvable. You got 2 variables in that. None of these are solvable per se. These are all 2 variable equations. You can't solve them. We could simplify number 10, but the value for the ordered pair for y is already in there, but it's not shown. So what does that mean?
It's 0.
It is 0. That's correct. Right. So you got the first part right because you identified your x value as -3 for the right-hand side, but the left-hand side is actually y plus 0, because that's the y value from that ordered pair that's in that particular equation.
Another thing that I looked at on the level one, so you don't get confused, is if you look at the problem, y comes first and then x. So when you think about it, and you want to say the first, like x, y, or whatever, you just look at where the letters are, and that's how you get the number. Good. I don't know if you guys at home could hear that, but she's identified a good way to remember, because you're starting off with a y term here, so that's got to be a y term in the left-hand side. On the right-hand side, you got x, so the other term inside the parentheses should be an x term also. So it's maybe another way to remember the difference. Number 12 is just the flip side of number 10. Now the x value is 0, right? Because we got the y value, which would have been -3. There's nothing over here where our value from the point for x is, so that's got to be also 0. The back side of this, the second page,
Let me pause here for a minute. I want to pull one of these into Jamboard. All right, sorry about that. Point slope, here's one of those problems from the back. It's got a spot here to put down what the point is and what the slope is. For me, the easiest thing is always to identify the slope. Slope is 1/3. The point, let's see, x value over here with the sign would be different. And so that x would be -1. Same thing here. For the y value, the sign would have been different. So that would have been -2. And the reason I'm just thinking out loud like that is because this is what it would have been originally when you substitute in the value for the point. You would have had the subtraction sign as part of the equation form. And then up against the -2 means change the sign. Same thing on the other side, 1/3. Gosh, these are hard to work with. X minus a -1. Keep change again. So I've got a point and I've got the slope. Anything else I need to graph? Nah. I can start at this point. -1, left 1, down 2. It's right there. Now positive slope's my line's going to go up to the right. So if I go up 1 and to the right 3, 1, 2, 3. It's going to be right there. Up 1 again, 1, 2, 3 to the right again. So there's my line going through from point slope, and all I had was 1 point on the line and the slope. Now, I'm going to show you this for the simple reason that sometimes converting into slope intercept is not what you want to do. You might not know that initially, but now that I look at this graph, look at the y-intercept here. You know, I know this isn't terribly accurate because my line's kind of squiggly, but it looks like it's somewhere between 1 and 2. So even if I took this original equation and I'm going to do that to show you here, but if I convert this, I don't think I'm going to get a y-intercept that's at a whole number. You know, I'd like a nice clean starting point, an intersection point, and not guessing, is it 1/3, is it 1/2, is it 2/3? You know, what is it? So if I take that original equation, y plus 2 equals 1/3 x plus 1. Whoops. Do the same kind of equation solving that we've been doing on everything else. Not going to do anything on the left yet because I got to get rid of that parentheses. So that right-hand side becomes 1/3 x plus 1/3 times 1 is 1/3. Oh, crap. So I don't have a whole number already. Now when I subtract 2 to get rid of this plus 2 on the left side, I got -2 combining with a positive 1/3. 1/3 x. So it's going to be negative. Whoops, wait a minute. How do I get that? Oh, it's supposed to be plus. 1/3, take away that from 2, it would be 1 2/3. 2 in thirds is 6/3. So 6/3 leaves me with 5/3. 5/3 is 1 2/3, which is pretty close to what I estimated when I look at the graph. That's somewhere, that's 1 2/3 negative. It's between 1 and 2. So if I had converted this to slope intercept right off the bat, it would not have helped me graph it. Because I don't want to be at some spot like that where I'm halfway or 2/3 in between two different whole numbers. questions, anybody? Okay.
I don't. That is fine for me.
All right. Hang on just a second. I'm going to switch gears now to talk about something that when we were all together, we always called the cover-up method to help us find intercepts. Okay, I'm kind of circling back to standard form here a little bit because Tuesday we were talking about converting these into slope intercept form. Because remember, standard form, we don't have slope identified. We don't have the y-intercept. So we don't even know where to begin. That conversion, every one of these, if I solve all these for y, that will work every single time. But there's an alternative that might be simpler in some situations. And that is to see if I can find the intercepts. If you remember that slideshow where we looked at the intercepts, for the y-intercept, x is always 0. For the x-intercept, y is always 0. So if all I'm trying to do is come up with the intercepts, I'm looking at what happens if I start to substitute some zeros in here for either the x or the y, and then solve for the other variable, because that could give me the 2 points that I need to graph. All I need is 2 points and I can draw a straight line. The problem is here, I'm going to have to end up dividing by these coefficients, right? So if I look at number 2 and I say x is 0, then if I'm in class, I'm doing it on the whiteboard, I'm actually going to put my hand over the 10x because 10 times 0 is 0. I don't even want to look at it anymore. So now I'm solving for y. That's all I got left. That's where the cover-up method name comes from. You physically cover it up. You can ignore it. So -3 goes into -15 just fine. So I could find that intercept. That's the y-intercept. Now if I reverse it and I try to find the x-intercept, meaning y is equal to 0, now I cover up that -3y. 10 doesn't go into 15 evenly. That doesn't help me. It gives me 1.5, -1.5. Well, I mean, at least that's a half. That's something you could probably estimate. Be better than nothing. And here's the graph for that same line. Look where that x-intercept is. Right between the -1 and -2. That looks like 1.5 to me. So you can do that if you want, if you don't mind the decimals. But the problem is on most of these graphs, our scale is in whole numbers. We don't have halves or thirds. What? 3/1? I'm not sure I understand your question there, Tony.
So you would cover the 10x and then 3 goes into 15 5 times.
Well, yeah, I get that. I'm talking about the actual line that was on there. Would it be like 3/1?
Well, if we're trying to find the slope, let's follow the line. How far do we have to go before it goes back on the line somewhere? It looks to me like it goes all the way down here. And I'll show you, let me show you this with the calculation. It'll make more sense. I'll come back to this drawing. Because I think the slope on this one is 10/3. Remember that number, 10/3. I'm going to write it down so I can remember too. So 10x minus 3y equals negative 15. So for the y-intercept, x equals 0 every time. The x-intercept is opposite. Because they're sitting right on the axis, on one or the other of those two axes. So that's why we can use 0 here and do some substitutions. So the first one I would try, the one that obviously works, is for the y-intercept. If I substitute 0, now I have a one variable equation. And I can find what y is, and it'll give me that y-intercept point. 10 times 0 is 0. Negative 3y equals negative 15. Dividing again by that coefficient. Both sides. So negative 3 divided by negative 3 is 1. Y. On the right side, I got negative 15 divided by negative 3. So there's positive 5. So the y-intercept is the point 0, not O, 0, comma 5. So there's the y-intercept. There's the division. And the cover-up part of this is I can kind of mentally check that out of the problem. Once I realize I'm going to substitute 0 for the y value, I don't even have to worry about it anymore. And if I'm doing this at the whiteboard, I'm literally going to put my hand over the number, demonstrating, of course, but so I don't have to look at it anymore because it's out of the problem. Because 0 times anything is 0. Why even worry about it anymore? So now we're going to try to find the x-intercept where y equals 0. See how that one comes out. Put the x back in there, minus 3. Now this one is times 0 equals negative 15. Same thing here. Ignore that negative 3 times 0. We got 10x equals, move this over, equals negative 15. Now I'm dividing by 10. 10 is my coefficient now for the x term. So x equals 15 over 10. I'm going to keep it as a fraction, 3 over 2. Divide both of those by 5. It's the same thing as 1.5. So my x-intercept, and I'm kind of doing it on purpose too to make it look even weirder, 3 over 2 comma 0. So that really doesn't help me a whole lot. But if I go back to this original and say, well, I'm confused. I don't like any of that. What if I just go to slope intercept? We're going to move the x term, divide by the coefficient of y. Move / cancel, right? Negative 10x. Both sides, negative 10x. Because now over here on the left, they cancel. Minus 3y now equals negative 10x minus 15. Now I got to divide by that coefficient of y to get the y by itself on every term. There's your 10/3. 10 over 3x plus 5. So our y-intercept is 0, 5. The x-intercept we had was 3 over 2, 0, or 1.5, 0. And our slope was 10 over 3. Now, if I've done that correctly, it all should match up on the graph itself. Okay, there's the y-intercept. 0 left and right, 5 straight up on the y-axis right here. The x-intercept, pointed that out earlier, kind of halfway between -1, -2. Now, this is where the slope gets kind of tricky, and it's hard to see on some of these drawings. So you blow this up even further. If all you're going off of is the graph, you got to really be careful. It would, and here's where I think you got your number, Tony. You went from 5, followed the line down to right there. That would be 3/1. But there's a little tiny speck of white in between the red line and the 2 graph lines. It's not exactly on those graph intersections. But if it's the scale of a sheet of paper, it's going to be impossible to see that. And it's now I've blown it up 400% and I can still barely see it. A little speck of white right there. So we got to keep going down this line, following the line. You got the same thing down here, only now it's on the other side of the line. So you got to go all the way down here to -5 before you get back in a clean intersection. So we went 10 down, 1, 2, 3 to the left. So 10 down, 3 left gives us a positive slope. Get this back down to some reasonable scale. See if I can find one where a lot of these you could use the cover-up method, like on number 10. That's going to be fairly simple to come up with intercepts. Because on number 10, if I make x equal to 0, then I got 4y equals -12. So y is going to be -3. So 0, -3. And if I make y equal to 0, x is just going to be -12. So it doesn't necessarily all have to divide every time. And the only reason I'm showing you this is because what I've tried to do ever since I got here 6 years ago was to show you guys the options. That's one of those special case lines. You go to where y equals 5, you draw a straight line across. That is the y-intercept for that line. That is a horizontal line because every single point on that line has a y value of 5.
And then if it was x, it would be the same thing.
Only it would be vertical.
Right. It would go over however.
Yes, vertical. They follow that form.
Okay.
Vertical lines always say x equals a number. Horizontal lines always say y equals some number. So, my goal here is to throw out some of these options and you guys run with the ones that you're most comfortable with. The one that will work every single time is converting. Solve all these equations for y.
So x plus 4 equals, or x plus y equals 4.
Mm-hmm.
How would you do that?
You're going to solve it for y, or are you going to do the intercepts? Okay, subtract x from both sides. That's it. The coefficient for y is 1, so you don't have to divide. Dividing by 1 doesn't change anything. That's the easy one. That's y equals -x plus 4. So what would your slope be in that case? Y equals -x plus 4. Uh-huh. -1. Very good. You got it. Yep. See, we were just talking about problem number 12 here, and that's another one of those conversions. Convert it to slope intercept by solving for y. It'll work every single time. So, shoot, I was hoping we'd have some more time to do some graphing today, but it doesn't look like it's going to happen. Anybody got questions? I'll be around tomorrow. I've got, yeah, Tony. Yeah, for sure. You need me to print it out for you? Okay. Absolutely. Anybody else want a copy of that, a hard copy? All right. All right, cool. Let me do that right now. I'll go ahead and end the class for the rest of you guys, and text me tomorrow if you need help on anything. Otherwise, we'll see everybody on Tuesday. Have a good weekend.
Thank you.